Hello students, today we are going to start with the very first chapter from first PU syllabus, that is some basic concepts of chemistry. This chapter is very important for board exams as well as the competitive exams, that is CET, NEET and JEE. So these are the topics that we will be covering in this particular session. So first topic is importance of chemistry, next nature of matter, third one properties of matter and their measurements, uncertainty in measurements, laws of chemical combinations, Dalton's atomic theory, atomic and molecular masses, mole concept and molar masses, percentage composition, stoichiometry and stoichiometry calculations. Here we will be talking about molarity, molality, normality, different terminologies related to solutions. So the first topic is importance of chemistry. Chemistry is called central science because it connects with different subjects: biology, physics, medicine, agricultural science, atmospheric science, chemical engineering and environment and many more. Now the question arises, where do we see chemistry? So the answer is almost everywhere around us. This we can understand little more in depth. For example, in daily life, when we cook food, you can see the color, taste, odor. There again, you can see the involvement of chemistry. When you go for any textile company, you can see the different type of fabrics. Even in the manufacturing of different fabrics or even in the dyeing process, you can see the involvement of chemistry. And even in the medical field, we are using different type of antibiotics, we are using different type of vaccines, we are inventing painkillers, we are using, all are chemical compounds. Soaps, detergents, sanitizers, again all these are all chemical compounds, or I can say products. So importance of chemistry in medicine is more important for board exams. So cisplatin and Taxol, these are the two drugs, well established and legally approved drugs which we are using for treating cancer. Again, azithromycin, this is also one of the most important drug for curing AIDS, that is acquired immunodeficiency syndrome. So now with this, we understood that chemistry is not something which is confined to a lab, it's everywhere around us. Now we are going to understand the nature of matter. So what is this matter? What comes to your mind if I say word matter? Matter is anything that has mass and occupies space and can be felt by any one or more of our sensory organs. For example, you take this marker, this has some mass. You take any book, pen, anything. Here I have given few examples: wooden chair, milk, oxygen, lightning. All these are all the examples for matter, because all this will have mass and occupy space, and that we can sense through any one or more than one of our sensory organs. So all these examples, if you observe, all this will have mass. So mass can never be zero, right? Weight can be zero because weight depends on gravity, whereas mass is not depending on gravity, so mass cannot be zero. So these substances can be in any of the state. It can be in solid state, liquid state, gaseous states, any state that we will understand in the next slide. Now, what does not occupy space and is not the examples of matter that I have listed out here? Love, respect, hatred, friendship, or any good manners, or these are the things which we cannot call it as matter, because this will not occupy any space or this doesn't have mass. So these are not the examples of matter. Now if we see the classification of matter, matter can be classified into two types: chemical classification, you can do physical classification. So under physical classification, matter can be categorized into three: solid, liquid, gases. Again under chemical classification, this can be divided into two: pure substances, mixtures. Again under pure substances, this is further divided into elements and compounds. Again, elements are further divided into metals, non-metals, semi-metals. Compounds are further divided into inorganic compounds, organic compounds. Similarly, when you come to the mixtures part, here mixtures are further divided into two: homogeneous mixtures, heterogeneous mixtures. Now, we can understand the physical classification of matter. So, physical classification means physical existence. We see whether the particular matter is existed in solid state, liquid state, gaseous state. Based on that, we can categorize that into solid, liquid, gas. You can see in solid state, this solid possesses definite shape and has a definite volume. If you see this part, these are all the examples for solid state. Next, if you see the liquid state, liquid possesses definite volume but no definite shape. Here, when I say solid state, it has both definite volume and definite shape. Whereas this liquid state has definite volume but this does not have any definite shape, because this will occupy the shape of the container when you transfer into that particular containers. Examples for liquid state is this. Next comes gaseous state. A gas does not have either a definite volume or definite shape. Here, these are all the examples for gases. Now, if we understand the characteristics of solids, liquid and gases, in case of solids, bonds are very strong. You can see a very strong intermolecular bonds. In case of liquids, relatively strong intermolecular bonds, slightly weaker than those of solids. You can observe in this diagram. Again, in case of gas, very weak intermolecular bonds. If you see the shape, in case of solid, there is a fixed shape. In case of liquid, there is no fixed shape. Liquids can take the shape of the container. In case of gases, there is no fixed shape again. Gases take the shape of their container. Next, if you observe volume, solids, in case of solids, there is a fixed volume. In case of liquids, liquids have fixed volume. In case of gases, gases do not have any fixed volume. Next, if you observe the arrangement of particles, in case of solid, particles are close together and vibrate around a fixed point. Whereas in case of liquid, particles are close together but not as close as solids. In case of gas, particles are very far away and you can see they bounce back randomly around the container. Next, if you see the density, in case of solid, fixed and quite high. In case of liquid, density is fixed and quite high, and in case of gas, it is variable and quite low when compared to solid and liquids. Again, if you observe interparticular forces, force of attraction is greater than the average of particles here. When it comes to liquids, force of attraction is comparable to average energy of particles. In case of gases, force of attraction is much less than average energy of particles. Again, if you see the particle separation, here particles are held close together, very tightly packed. In case of liquids, close but slightly separated. In case of gases, widely separated. And if you see the diagram here, in case of solids, you can see all these atoms are very tightly packed and you have a regular arrangement of atoms, whereas here you cannot see this much regular arrangement, but still some type of arrangement is there. But when you see the gases, here atoms are moving very randomly in all 360 degrees. Now, in this slide, you can see how the atoms are arranged in case of solids, liquids and gases. So, in case of solids, you can see all the atoms are very closely packed, whereas in liquids, there is a slight space when compared to your solids, whereas in case of gases, atoms are very randomly arranged. Very weak intermolecular forces are involved in case of gases. In the previous slide, we have studied the classification of matter into three. One is solid, liquid, gases. Again, we have two more states, that is plasma and Bose-Einstein condensate state. So, plasma state, this we can see in stars, lightning and even in fluorescent tubes. You can see how the ions are moving in plasma state. Again, if you see Bose-Einstein condensate state, again this can be visualized under very cool temperature. You can see ultra cold state of matter where particles behave as one quantum entity. So this is one of the research picture which I have taken. In this slide, we will understand the interconversion of matter from one state to other state. Here you can see, I have taken solid state, I have taken ice cube. This is in solid state. When you increase the temperature, solid gets converted to liquid, and this process we call it as melting. Again, when you take liquid water, again if you increase the temperature, this liquid is getting converted to gaseous state, and this process we call it as boiling. Again, if you take gas, if you see the conversion from gas to solid, this process we call it as deposition. Again, if you are taking any solid material and if you are converting directly that to the gas without going through the liquid phase, that we call it as sublimation. So the best example for sublimation is camphor. If you take camphor and keep it out for some time, automatically you can see the solid camphor gets converted to vapors or gas. Again, you can see if you are taking a gaseous substance, if you try to lower the temperature, automatically it gets converted to liquid state, and that process we call it as condensation. Similarly, if you take any liquid substance, if you are converting liquid to solid by lowering its temperature, that we call it as freezing.